Greetings, M Squared here, and we are going to go through two algebraic proofs today. So our algebraic proofs start off with a given information, which is a linear equation, and they tell us what we need to prove, which is pretty much the answer for that equation. And so we kind of know the answer. So if we get done with our proof and we don't get x equals 15 on this one or n equals 8/15 on this one, we know we did something wrong. That's kind of the cool part about it. But the other thing is, we're just going to solve kind of on this side. We don't have to show as much work as when we solved normally, and then we're going to give the reasons on this side. So let's get started. The first thing we want to do is just pretend like we're solving an equation and say, what would we do to get x alone? Well, this side, there's nothing we can do because we can't combine 20 and 6x, but on this side, we can get rid of the parentheses using distributive property. We are going to use our properties to fill in this right column. So we're going to leave our 20 plus 6x on the left side because there's actually nothing we can do with that. And we're going to distribute that 2 on the right side, so we get 8x minus 10. And whatever property you used to do whatever step you just did, that's what you're going to write over here. So this is the distributive property. And I'm just going to abbreviate distributive property of equality. Next, we have a decision to make. We can either move the constants or we can move the variables. I'm going to move the variables first. So I'm going to subtract 6x from both sides. I don't actually have to show that I'm subtracting 6x. I just have to subtract 6x. And when I do that from both sides, cancels on the left side, and I get 2x on the right side because 8x minus 6x gets me my 2x. What did I do? If I subtract something from both sides, that's the subtraction property of equality. Okay, what do I have to do next? Now I have to move my constants to the left side. So I'm going to add 10 to both sides. And when I add, that's going to be the addition property of equality. So I'm going to get 30 equals 2x. Next, I'm going to divide both sides by 2. And that, you guessed it, is called the division property of equality. Now here is where you're going to have to get used to different. When we see 15 equals x, we think we're done because x is alone. But remember, they asked us to prove that x equals 15. And I know in our minds we think those are the same thing, but in geometry it's going to get really particular and you're going to have to get used to that. So I have to get it to where it equals x, to where it says x equals 15. And I have to have a reason for doing so. That's why we just learned those 3 properties, reflexive, symmetric, and transitive, because we're going to be using them. And the symmetric property says that I can just switch what's on each side of the equal sign. So that's what I'm going to do. I'm going to put the x on this side and the 15 on that side. And how can I do that? Because that's what the symmetric property says. So I'm going to just say symmetric property. All right, kind of weird, but that's what we get to do when we get to this level. So exciting stuff. All right, now we are going to solve this one. I'm going to show you a little bit of a shortcut here. You'll notice that distributive property could be used on both sides. I'm going to do those both at the same time, but you could use 2 different lines for those, but I'm not going to. The lines are kind of just a model. If you use more or less, it's fine. I just put the lines there, kind of what the average might be. So we're going to get rid of the parentheses on both sides by using distributive property. So here we go. Remember, distributing this negative is kind of like if there was a -1 out there and I said -1 times 3n and -1 times -4. It's kind of how that works. 2 times 6, 2 times 5. How can I do that? Whoops, I forgot my little number there. Distributive property. Okay, what next? Well, now we didn't learn, this isn't called a property, but do you see that the 14 and the 4 are both like terms on the left side? What we can do is combine like terms. So that's what I'm going to do next, and I'm just going to call it combining like terms. So I've got 18 minus 3n. Now, if you learn more properties than I taught you in class, then you could do some other things, like you could switch the order and call it commutative property. And anyway, there's more to it that if you're in another class, not mine, you might have to do, but we're not going to do that in this video. So that's just combining like terms. That's what we're going to call it. now we can move the n's to one side and the constants to the other side. So let's see, we'll move it to this side first, and then we'll avoid using this symmetric property because it said n equals 8/15. So we're going to subtract 12 from both sides. And what did I do? I used my subtraction property of equality. And then I'm going to do that again because I need to move the 18 over. And when I do that, I get negative 15n equals negative 8. And that is sometimes, this is a little shortcut, sometimes I just put little quote marks saying, hey, I just used the same thing I did before. That's okay to do too. I like shortcuts. And finally, we're going to divide both sides by negative 15, and a negative divided by a negative is going to be a positive, and that's how we get our n equals 8/15. So we use the division property of equality. And once you have on the last line, well, oh, sorry about that. The last line will always be what you were trying to prove. That shows you that you're done, so that's kind of cool. And remember, this is getting us ready for geometric proofs coming up soon. So good luck with that. I'm Squared signing out.